All right, welcome. We are continuing on section 4.3 in the Lock 5 statistics book. And we introduced at the very end of the last video significance level. Alpha, denoted alpha, is the threshold for which p-values is deemed small enough to reject the null. So if the p-value is lower than significance, the null must go. If p-value is high, greater than significance, the null will fly. Okay, so often, and if we're going to use 5%, 0.05 for significance level unless otherwise specified. This is the most probably standard, although I'd say standard for social science at least. And why 0.05? So there's this psychological experiment that's been done multiple times. I've actually tried to kind of mimic it in my classes, statistics classes in the past. And go something like this. I come into class, and I tell the class, I got a deck of cards that I'm shuffling in my hands. And I say, all right, I'm going to pick 7 cards. And for every card, I'm going to give you some extra credit on the next assignment. Every black card I pick, I should say. So I'm going to pick 7 cards. First card I pick is red. All right, no one seems to care because that's 50% chance you get a red card. Second card I pick, also red. All right, that's possible. You get 2 red cards in a row, about a 1 in 4 chance of happening. 3 cards in a row being red, that has about 11-12% chance. So you usually red on 3 cards. A couple students were wondering if the fix is in somehow. Then I pull a 4th card, it's also red. So 4 red cards in a row. And this is usually when the class starts thinking something's wrong. You're not giving us extra credit, aren't you? So sad. And then the 5th card, if I get to 5 cards in a row, all red. Usually, 4 and 5, most of the class is thinking, okay, something's wrong. This is a stacked deck or whatnot. And then just for the heck of it, I pull 2 more, 6 and 7. I get 7 red cards in a row. And 7 red cards in a row, the probability of getting 7 red cards in a row is less than 1% chance, 5%. So a couple statistical studies have shown, psychological studies have shown that at least for humans, we start to get really skeptical around 5%. We start thinking something is off. Even 12%, 10%, we think that happens. Unlikely, but definitely happens. It's usually right around 5%. So if this helps, this might be one reason why 5% is used a lot for significance level. All right, so kind of to summarize, if the p-value is less than alpha, and usually it's 5%, but not always, sample results would be rare if the null were true. This means we reject the null hypothesis, and that means we have evidence that the alternative hypothesis is true. If p-value is greater than or equal to that significance level, sample results would not be rare if the null were true. That means we do not reject the null. And don't forget, we never accept the null. We just reject it or do not reject it. And our test is inconclusive. This is why we'll talk about later. If the p-value is less than alpha, the test is statistically significant because we have evidence that the alternative is true. On this right column, if p-value is greater than or equal to alpha significance, we say that the test is not statistically significant. All right, and the test to see if the mean body mass is lower after treatment, the p-value is 0.007. So we're going back to the lemurs, taking a red wine supplement. If we got a p-value of 0.007, using alpha equals 0.05, what should we do? All right, don't forget, if the p-value is low, the null must go. And that low is less than significance, so 0.007 is less than 0.05, so we reject the null hypothesis. All right, and the test to see if mean body mass is lower after treatment, after the red wine supplement, the p-value is 0.005, so we reject the null. What can we conclude? Evidence shows that mean body mass is lower after the supplement. Or evidence shows the mean body mass is not lower, or nothing. In this case, evidence shows the mean body mass is lower. We'll go back to the alternative hypothesis. The body mass afterwards was less than the body mass before. to test to see if the mean locomotor activity is higher after treatment. The p-value is 0.49. Using alpha equals 0.05, we should do not reject the null. Don't forget, reject and not reject always refers to the null hypothesis, not the alternative. So if the p-value is not lower than our suggested significance level of 5%, we do not reject null hypothesis. So with the same scenario, what can we conclude? Locomotor activity changes after supplement. Locomotor activity does not change. Or part C, we do not have sufficient evidence to conclude anything. We are part C. We do not reject. Remember, this is a not statistically significant hypothesis test. Okay, so this part's a little extreme, but to kind of reiterate why we never accept the null hypothesis, we never are going to say it's absolutely true or false using statistics. Let's say we have H naught is X, some animal is an elephant. The alternative hypothesis is X, some animal is not an elephant. Okay, so this null hypothesis is on trial. Is this animal an elephant? And we only have the evidence that X walks on 2 legs. So what would you conclude? I think any most reasonable rational people would conclude reject the null. Evidence is that X is not an elephant. Elephants do not walk on 2 legs. You have very high probability of that being true, but here's a case where that's not always true. Sometimes elephants do walk on 2 legs, albeit for a very short distance. On the flip side, if you're given evidence that X has 4 legs, or walks on 4 legs if you want to say, is that strong enough evidence that the animal's an elephant? I would say no. But if you have a dog or a cat or a caribou, many animals have 4 legs. So we do not reject the null hypothesis, but we don't say it's true either. We can't say the animal's an elephant. We just don't have evidence to determine whether X is an elephant. Maybe if we knew it walks on 4 legs and has a trunk, getting closer. So again, think about in a court of law, which we talked about a couple times already. What is at least in the United States, the jury finds the defendant guilty or not guilty. Same scenario here, either the null hypothesis is guilty, reject, or not guilty, do not reject. The jury never finds the defendant innocent, and we are never going to declare a null hypothesis true. All right, never accept null hypothesis. Do not reject is not the same as accept. We can't say it's true, it just means we have lack of evidence against the null is not the same as evidence for the null hypothesis. And Fisher is a famous statistician, pioneered a lot of the techniques that we're using still in this class a couple hundred years later. For the logical fallacy of believing that a hypothesis has been proven to be true merely because it is not contradicted by the available facts, has no mere right to insinuate itself in statistical than other kinds of scientific reasoning. So what he's saying is just because we don't have evidence against something does not mean it's true. So never accept the null, reject, do not reject. Okay, statistical significance. When the p-value is less than alpha, the results are said to be statistically significant. If our sample is statistically significant, we have convincing evidence against the null and in favor of the alternative hypothesis. So basically it's the same chart as before. If the p-value is less than alpha, results would be rare if the null were true, so we reject the null. At the same time, we have evidence that the alternative is true. Again, I like this terminology, evidence for results conclude, never true or false. And if the p-value is greater than or equal to alpha, results would not be rare if the null were true. So we do not reject the null. Again, never accept, but we do not reject the null, and our test is inconclusive. So on the left, if the p-value is less than alpha, that's when we say the results are statistically significant. If p-value is greater than or equal to alpha, results are not statistically significant. On the test to see if the mean resting metabolic rate is higher after treatment, the p-value is computed to be 0.013. So using a 5% significance level, is this statistically significant? Yes, p-value 1.3% is less than 5%. P-value is low, the null must go. And if the null must go, that means we have statistically significant results. If the mean resting metabolic rate is higher after treatment, the p-value is 0.013. What can we conclude? Okay, we rejected the null. We have evidence that the mean resting metabolic rate is higher after the supplement in lemurs. All right, in the test to see if mean food intake is lower after treatment. Do lemurs eat less after taking this red wine supplement? We get a p-value of 0.035, and we're using now significance of 10%, 0.10. Do we have statistically significant results? The answer is yes. P-value is low, the null must go, and that is the same as saying we have a statistically significant result. All right, so we have the same exact sample, same exact p-value, 0.035, but what if we use in alpha a significance level of 1%, 0.01? In the same exact test, the same exact data, we would say, no, we do not have statistically significant results. P-value is greater, 3.5% is greater than 1%, so results are not statistically significant. So for the statistical conclusions, a lot of times, you're doing your online homework, they're just going to ask, do you reject or do not reject? So for based on 5%, anything greater than 5% do not reject, anything less than 5% reject. But generally, that's not really how this works. It's really kind of evidence for or against. The closer the p-value is to 0, the stronger the evidence against the null hypothesis. So right here, the black and white world, is it reject or not reject? You would not reject at 5.1%. You would reject at 4.9%. But in practicality, those are very similar. So we have this kind of artificial cutoff of alpha, but generally, if you have around 5%, you might want to do some more tests, more sampling. All right, conclusions over here, p-value is less than alpha. The generic conclusion is reject the null hypothesis. The conclusion in context is we have evidence that the alternative hypothesis is true. If p-value is greater than or equal to alpha, the general conclusion is do not reject the null. And the conclusion is we do not have enough evidence to conclude that the alternative hypothesis is true. There's a lot of double negation in the statistical hypothesis testing. Notice, and we'll practice some of this in class, what is the null hypothesis and at homework. Do we reject or not reject? But then the conclusion should be written as in terms of the alternative hypothesis. Okay, we'll go over this next example in the next video.